3 of our class. And with this, we're almost done with, what do you call this? First quarter. Okay, so let's begin. So these are our objectives for our lesson this week. Models real-life situation using quadratic functions. Represents a quadratic function using table of values, graph, and equation. And transform quadratic function defined by the general form y equals ax squared plus bx plus c into the form y equals a squared quantity of x minus h plus c. So we have here this picture. If you will describe this, we have a man playing golf, a banana, the McDonald's logo, and 3 dolphins. Okay, now what does these 3 pictures have in common? Well, according to the answers of most students, they all project a curve. Okay, so that is right. They all project a curve. So with that, let's proceed. We will elaborate on these pictures later. So part 1 of our discussion is all about quadratic functions. Okay, so to proceed, here are other examples of situations that models quadratic functions in real life. The first targets an object in an upward direction, throwing an object downward, shooting ball vertically upward, minimum point submarine to submerge, and launching rocket to its maximum point. First example, we have here f of x is equals to x squared plus 6x plus 8. This is a quadratic function since its highest degree is 2 and all numerical coefficients are real numbers, meaning the value of your a, b, and c were all real numbers. In that case, they were 1, 6, and 8 respectively. Okay? Another example, y equals x squared plus 4x plus 4. This is not a quadratic function since its highest degree. This is a quadratic function since its highest degree is 2. And all numerical coefficients are real numbers. In that case, we have 1, 4, and 4. Another example is y equals 7x plus 12. This is not a quadratic function since its highest degree is 1. Therefore, this is a linear function. Okay? Last example, we have here f of x is equals to the quantity x minus 2 times the quantity 3x plus 3 times x squared. This is not a quadratic function because if you will expand the right side, its highest degree will be 4. Meaning to say, if you will multiply x times x, you'll get x squared. And multiply it as well by x squared, and you'll have x raised by 4. Okay? So I hope that clears that statement that this is not a quadratic function, though you see a square here, because you have to remove the parenthesis sign before this one is considered a function or an equation. We have to remove the parenthesis. Okay, so with that, what is quadratic function? A quadratic function is a second-degree equation in two variables. This is the difference between quadratic equation and quadratic function, simply because quadratic equation works with one variable only, while function or quadratic function works with two variables, and they are represented as f of x is equals to ax squared plus bx plus c, or y is equals to ax squared plus bx plus c. Take note that f of x also means y, or y means f of x. They are just equal. And to be considered a quadratic function, a should not be equal to 0, because if a is equal to 0, then that is considered a linear function, where the values of a, b, and c are real numbers. Okay, this is almost a repetition of the definition of a quadratic equation, except that it works with two variables. In this case, that would be most of the time x and y. 3 ways to represent a function. First is by table of values. Second is by an equation. And third is by a graph. So we have here the table of values. A table of values is a table of the value of x and y. So we have here the x and y. Now, how can we identify if the given table of values is a quadratic function? So let's focus on the y values. Okay? For us to identify whether the quadratic function is, or whether the table is a quadratic function, there would be two options. You graph it and then see what the graph is. See how the graph looks like. Another example, to know if this is a quadratic function, we'll have to do this. We have to subtract each pair of values of y. So 3 minus 0, that is 3. 0 minus negative 1 is 1. Negative 1 minus 0 is negative 1. And 0 minus 3 is negative 3. Then we'll repeat the same process with this group of numbers this time. So 3 minus 1, 2. 1 minus negative 1 is also 2. And negative 1 minus negative 3 is 2. Now, if in the second layer of the differences of the values of y appears that they are similar, then you will consider this table of values a quadratic function. Okay? Let's have another one. Again, let's focus on negative 2, 0. Minus 0 is negative 2. 0 minus 2 is negative 2. 2 minus 4 is negative 2. 4 minus 6 is also negative 2. So unlike with the first example, you have noticed that we already have similar differences on the first layer right away. So with that, if you see that the differences are similar on the first layer, then this is not a quadratic function. This is a linear function. The similarity of the differences must appear on the second layer. Okay? Another way to represent a quadratic function is by its graph, meaning you have to plot these points on the Cartesian plane. Okay? So let's do negative 5, 3, negative 4, 0, negative 3, negative 1, negative 2, 0, and negative 1, 3. Then connect all points. Now, as you can notice, just like with the previous example or the pictures that we had a while ago, you now see a graph which is a curve. And this curve is what we call the graph of quadratic function called a parabola. This curve-like graph is called a parabola, and it's the graph of quadratic function. And the different properties include the vertex. This is your vertex. It's either the lowest or the maximum point. You also have the axis of symmetry, the opening of the parabola, and the x-intercepts. So, if you have a parabola, then that's a quadratic function. And the third way on how you can solve quadratic function or represent a quadratic function rather is by an equation. This y equals ax squared plus bx plus c is what we call the general form. We can transform this to what we call y equals a times the quantity x minus h squared plus k. This is called the vertex form. Why does it be called a vertex form? Because the value of h and k in this equation is the vertex. That is why it is a vertex form. Okay? So, let's begin with y equals x squared plus 6x plus 8. So how do we do this? Group together the terms containing x. When we say group together, you'll just have to put a parenthesis. And the terms containing x are the first two terms, x squared plus 6x. So we group them together by putting a parenthesis. And the next step, factor out a. If a is equals to 1, proceed to the next step. Since a is equal to 1 here, we will proceed to the next step, meaning we don't have to factor out a if it is equal to 1. And then next, complete the expression in the parentheses to make it a perfect square trinomial. So with that, let's copy with x squared plus 6x. How can we find or how can we change x squared plus 6x to a perfect square trinomial? Divide the second term by 2, and the answer is 3, and multiply by itself or square. And the answer is 9. Add it there, and after adding, subtract it and copy the last term 8. Okay? Next, simplify and express perfect square trinomial, a PST, as a square of binomials, SOB. So in this trinomial, we're going to express this as an SOB. How do we do that? Let's just do this. Square root of x squared is x. Copy the sign of the second term, then get the square root of the last term. That's why you have 3. Then enclose it with a parenthesis and raise it by 2. Now, how do we get negative 1 here? Negative 9 plus 8 is negative 1. So this is now your vertex form. from the general form y equals x squared plus 6x plus 8, you now have y is equals to the square of the quantity x plus 3 minus 1. Another example. So it says here, group together the terms containing x. So I group the first and the second term with a parenthesis. Then we're going to perform factor out a. Since the value of our a is not equal to 1, we're going to factor it out. Meaning to say, bring out 5. Okay? We have here 5 now. What becomes of this? 5x squared divided by 5, you'll have x squared. Then negative 20x divided by 5 is negative 4x. Then copy negative 5. That's what happens when you factor out a. Next, complete the expression in the parentheses to make it a PST. Okay? Copy 5. Then x squared minus 4x, copy that. Divide this by 2, that is 2. Multiplied by itself, that is 4. Add it, then subtract it again. Place a bracket, then copy minus 5. So if a is not equal to 1 rather, it is quite a long step, but still very easy. Okay? Next, simplify and express perfect square trinomial or PST as a square of binomials, or what we call SOP. Okay? So copy 5. Square root of x squared is x. Copy the sign of the second term. Square root of 4 is 2. Then place it on a parenthesis. Then raise it by 2. Then copy negative 4, bracket, copy minus 5. Okay? Next step, distribute 5. So we can remove the bracket. We have to multiply 5 to the square of x minus 2 and 5 times negative 4. If you will multiply 5 to the square of the quantity x minus 2, the answer is this. And 5 times negative 4 is negative 20. Now we have removed the bracket. Copy the negative 5. The next step would be the final answer. So, copy this part and then simplify negative 20 minus 5 and you'll have negative 25. This is now your vertex form. Okay? So, that's the end of our lesson and I hope that all of it were clear to you. See you on the next video tutorial. Thank you.